Hello everyone, I'm Zhiyaogang. Okay, let's continue. Let's look at this property. We're looking at attributes now. Okay, actually, attributes are very simple. You just write an attribute and add a property. For this part, let me think. We should probably just look at the official documentation. That should be fine. Okay, because the official documentation here is already very comprehensive, we need to thoroughly understand it first. Come on, we mainly built the chain first, and then I'll supplement it after, from my personal understanding. And this is its declarations specification, that you need to use standard UEC ++ syntax to declare it. Then there is a macro. There are two variables inside the macro. The first one is the specifier. It should be called a variable specifier right. And then there's the metadata, and this is a change specification. And then we can see the integer types in Unreal Engine are these, like 8-bit, such as bit, 30-bit, that is 4-bit, 8-bit, 10-bit, 100-bit, that is 4-bit. We generally use int32 and uint5. So what are their respective application scenarios? As long as we use integers, we generally use int32. Then use int8. Sometimes we use custom data. That is uint8. We will use this, yes, and then when we use RGB data, we will use, because we know the RGB values, it is actually something like a 8R, 8G, 8B8. So these two data types, we use them quite often. If you are relatively simple, we can just put it directly in this project. It's already there. Let's create a new one here. I'd better create a new actor here. Create a new actor here. Then let's name it Excite Property Public Actor. Okay. Then let it refresh itself. Let's continue. Look at this. Just overwrite it. That's fine. Hey, where did it create it? It's still placed here. Not great. Don't worry about it. Actually, writing it out here like this is fine. That should be it. We call it myEvent8. We can give it an opt. Let's attach one here. This macro teacher. Good. There's something to say. Property. Then we give it an editor. Make it readable and writable in Blueprint. Blueprint readable and writable. Then EditAnywhere. Then header graph. XGOK. So it's actually like this. Then if you want to implement it, you can do it like this. Do it this way. Let's check if all types support reflection to Blueprint. Let's take a look. Okay, I'll quickly paste it here. We type in the return color. Careful not to delete the part after it. Let's compile it. Hey, you'll see that it doesn't support it. No wonder I didn't see how Blueprint people would encounter it, since there's this issue. Let's just write the rest as well. For the rest, we'll do it like this. Let's just let's just 1 1 1 1 1. Okay, now let's compile it. Hey, wait, I clicked the wrong thing. Okay, you'll see that none of these are supported, right? We'll just block them. We just need to block them in red. uint16 3 into 192. Take another look. It proves that other data types are supported in this place. Just set it to equal 0. We need to remember to initialize the variable at all times. There are some issues on the other side. Now let's see what it looks like in Blueprint. And if we want to view it, actually, here we need to inherit a subclass to see it. Otherwise, if we click over there, it will directly be this code. Okay, you see, it looks exactly like this. Exactly like this. Okay, here, we can actually check it by ticking it. U-Unit-64. It was originally this type. So Blueprint also has this integer x64 type. Look, if it's were uint 8. Click here and take a look. This is relatively simple information. If you've played with Blueprint, it's easier. Okay, then let's erase this. Erased. Okay, so we mainly look at this. This is what I wanted to tell you in the last lesson. That the concept of uncoupled code. That is, it can check multiple items at the same time. So let's first take a look how it is declared. Basic metadata in bitmask. Let me see. It is called through a function. Let's first write and declare it. See what it looks like. We'll declare it here as well. We'll just erase it. Let's copy it. Let's start it now. See if we can start it. This version also reports an error. Let me check. See, that's him. Basic math. We can check many of them. Its solidity. Actually, we know 1 byte is 8 bits. If I use the first bit to represent the first bit, if the first bit is 0, then it is unchecked. If the second bit is 1, then it is checked. So for the numbers 0, 1, 2, 3, 4, there means nothing is checked. 1 means the first one is checked. 2 means only the first one is selected. The second 3 means the first 2 are selected. 1 byte is 8 bits. This is how it should be understood. So this thing is a relatively special high-speed usage. We don't usually use it this way. And this is when, in the blueprint function, you can pass this thing. We can try to write this method. Then of course here you might only see this flag. We can use some other methods to get rid of the flag's name. Now let's paste this code over. Okay, we may need to implement this method. A semicolon might need to be added here. This should work now. Let's just paste the data key. Let's see if it compiles. Unexpressed underway cannot follow from definition. This error is more troublesome to deal with. Okay, let's first check if it's this thing is hanging. An encoding issue. It turns out it's not an encoding issue. I'll check it later. Okay, it works. I haven't used this open for too long. Just this thing. This is not needed after that something. You can just remove it like this, because when defining, this is only used when our UHT scans it. To let it declare another function for use. Here, we will just print this thing to verify what we are talking about, whether it is the 01234 approach I mentioned. This is to help you learn. This log will be explained later. Looking at boarding, I think there is none. bxt. Look at this function. Okay, no, these 2%. Then we can just fill in this parameter later. This log will be explained later. Let me first finish explaining the basic framework to everyone. Hey, okay, when we call this method, it will pull up this number. Now let's go into the function, let's call it and try it out. Good. Then next, let's create a map. Create a map. Let's call it property puberty map. And then we'll just drag our C++ class over. It should be this one. In Blueprint, get its reference in the level blueprint. When we press the key, aka bolt, then here, we call the method called myFunction. Yes, look here. It converts this integer into this flag. Let's test what flag 1 is. Let's just use 1234. We'll use 1234. We'll set this one as a flag. We'll set this one as 2. For 3, we'll set it as 3. Two, 3. Okay, let's give him a 4. Note, we need to connect this, otherwise it will report an error. Then check both 1 and 2. Okay, in this case, let's test it. For 1, nothing should be checked. Let's look at the printed log. If nothing is checked, it's all 0. Then it proves there is no problem. If we check the first option, it should be 1. If we check the second option, it should be 2. If we check both options 1 and 2, there should be 3. Right? Because we are using bits. The first bit of the byte, if both the first and second bits are checked, then it's 0000011, ling, 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 e. That's 000101. That's what it means. You probably don't need to draw a diagram for this part, right? Just understand it, okay? Understand the concept of bit again. Okay, next, let's continue looking further ahead. Sometimes we need custom names. So we should use this method to define custom names. Note that actually it only has the range is 0 to 31. Then 0 corresponds to this bit of sharp. We can take a look. I think declaring it this way might be better. Let's paste both of these in and take a look. As for the definition, we'll put it here. Then we give it a 1, okay? Then here we take a look. We give it a 2. Save it. It prompts you. Do you want to receive first in order to maintain? Unicode character in fail. Let me take a look. It seems there's a problem. This is an encoding issue, so let's just save it directly. Let's check its encoding now. Yes, sometimes when writing files, the encoding might get messed up. Okay, let's first make sure it compiles. See if it can pass compilation. It still can't pass. Right, let's extract it. Maybe some strange stuff was extracted. Let's see what this error is. This part seems to be extra like this, right? Okay, so actually we generally declare that this enumeration is done, and we can also make a correspondence. Then when using it, just paste this over. Let's put it here and take a look. Actually, this one is a bit special in meaning. Yes, let's take a look first. Because this thing is used less often. Usually, through optimization, when performance optimization is heavily emphasized, and when there is this kind of interaction between attributes, when multiple tags need to exist simultaneously, we use this thing. Then let's take a look at this. You can see here its color tag doesn't seem to have changed. Let me check again. The reason it didn't change is that we added a 1 and a 2 here. Let's change it anyway. We still color Tajira. Let's compare and see the effect. Okay, 1, 2. This means you can use more than 32, but you can only see 32 in the editor. This is easy to understand, right? Okay, now let's take a look. Hey, look, it appears here, right? There should be no problem. Okay, so that's how it's used. Then actually, let's go back to this document. Let's paste this function in and take a look. Where would this thing be used? I can give you an example later. So, let's close it first. Let's paste this function in. Okay. Then we also need to create it. For this creation, let's just paste it manually. Because sometimes the creation method with red sometimes throws an error. Okay, we do the same like this. It is equivalent to specifying this int data, map into this color bytes. Let's map it to 1 and take a look. We map it to 2. In 2, let's check the corresponding relationship, whether it's correct in quote. Okay, there's an issue. Let's see what the problem is. Obviously, we are missing a semicolon here. Yes, we often miss semicolons when writing code. Okay, alright, let's extract this function. It should be done like this. Cool. See, this part is very clear. Now let me explain this to you. Where is it most commonly used? Actually, we have something called enemy media. This. See? What is this used for? It is used for each round. Your scar. Let me take a look. Let me take a look. I still remember how to do it. I'll explain it to you later. It can be done on a per round basis. The devices connected to your computer can be listed one by one, and it has a filter. I don't quite remember the relevant code. We also have it officially. We'll cover it when we encounter it later. When I teach you how to read camera data, I will explain it in detail. Okay? This lesson didn't feel like it covered much content. Only 20 minutes left. Okay, so This bitwise research code is an advanced technique. Let's continue looking below. Then, this is the floating point type. Floating point type. Double and flutter are both fine. It can be deflected. Then this is the boolean type. We usually use the following notation. Starting with a lowercase b. We generally don't use this notation much, because C++ prefers this notation for alignment, memory optimization, memory and such. I also like to use it myself. We generally just use boolean directly. Okay, then let's still show it to everyone. Show it. They're all relatively simple. Actually, okay. Let's see if it compiles successfully. No problem. Then we can open it and take a look. Let's see what it looks like in our editor. Actually, wait a moment. Here, most importantly, let's add this one back. This thing isn't right. We don't need it anymore. We need this one behind. Then we need two auxiliary dictionaries, one float and one double. Let's make it a float. Make it a double. Okay, let's take a look. Right here. Float double, right? Then we should actually take it down. Let's check and open this variable. Hey, this is called boolean, right? Whether angry and threats are possible. This kind of float. My float. Yet it should be scrolled to the very bottom. You can see my float. They are actually all green. They should all be double precision. It should have been extended by the team that wrote it together. Okay, it used to be flow, I think, right? Previously, large packages could not be reflected into Blueprint. Then there are our strings. String, FName, FText. We'll just demonstrate it here for everyone. String, FName, FText is also acceptable. What is the positioning of text? FName is the string we commonly use. It is used all the time. FName is used to create a globally unique identifier. Globally unique and immutable, a case-insensitive string. It is actually somewhat like a string constant. Anyway, the official documentation says it is relatively small and can be passed efficiently. But in practice, sometimes we 7T don't really use FName for network transmission or synchronization processes. I remember some expert once said that this might be better or something. Anyway, let's not worry about it. Then this FText localization is that you write an original text and then you mark it as A. Then it translates to the letter A in Chinese. What does it translate to in Arabic numerals? That is its language. When you write it, you use K to represent the text at this position. Then each K translates into a different new one. So K1 translates to Gaogang. K1 translates to Gaogang in Chinese. Then K1 translates to XG in English. Well, that is how they are. In our project, they are actually all the K1 value. Okay, this string is relatively simple. These collectors need to convert between each other. We'll talk about this later. As for our string, actually, I can still add a bit more explanation for everyone, and it's the computer fast. Just write it directly. Then let's write it like this. Let's also initialize it first. FString, then flame. And for the FString, we'll call it mist. We need to initialize it. We need to calculate. I am a string. Saying string. This double is the same. Flam, let's initialize flam first. Flam should be directly initializable like this, because it overloads this equal sign. So it should be directly initializable like this. As for FText, let me check. It doesn't seem right. FText is more complex. You need to use that NS local thing. Generally. Take a look here. See if we can get it out. Just give a random one for the first. It should be called myActor. Its scope, the first one should be second. The second one is its key value. As for its key value, we'll call it mydouble. Call it mydouble. MyDix. This one is called myName. Come on, txt. We'll translate it for him. I am uniform. String wave. Okay? Now let's see if there are any compilation errors. It might possibly. As expected, an error was reported. Let's adjust this value to see if it was caused by it. Okay, it was indeed caused by it. There's no problem here. Then this approach might not work. Let me see how to write it. Writing it this way should be able to. Actually, I think we should just write it like this. It should be fine to write it directly like this. Can we write it like this? Let's just delete this directly. It doesn't seem to work. They might not be the same thing. So we won't do it this way. Okay, now let's take a look at what our blueprint looks like. System creation is something that requires careful explanation. It needs to be explained step by step. Because in system creation, we often perform operations like adding, deleting, modifying, and querying, concatenation, extraction, comparison, and so on. So here we are just looking at it from a conceptual perspective. Look, you'll see that they look like this. This is blueprint knowledge. I won't go into it. Just take it as is. That's fine. So that's done for the text part. Now let's talk about this property specifier. It hasn't been translated yet, right? This is advanced play. This property will be placed in this .prop. It might only be viewable in the drop-down menu. This can be searchable when registering assets. This thing is very important. We often do this multi-weave delegation. What is multi-weave delegation? It's similar to the world dispatcher in blueprints. That kind of thing. It means binding something like this. This also seems to be related to multi-weave. It can only receive this target, maintain this blueprint, this authorized blueprint authority, only allowed, and this is what we often use. This property Shepherd. Actually, this is used inside a function. This is used inside a function. This is a get method. There is a custom get method. This is BlueprintReadOnly. That means there is no set. There is no set method. How should I explain it to you? It's quite simple. Actually, if I have a variable here, it's not a 4-column dispatcher. Normally, this variable has a get, and it has a set. But if I restrict this thing, then it can only get or only set means this. And it is a custom set method. Then this is the classification. This is for config. It will take these categories of ours and essentially put them into this ini file. You can see that we have some configuration information. When we want to display it back in the ini, we make some development settings. That is how we take these things. Take these things and reflect them into the ini file. Actually, it uses this config metadata. This is recent. Haven't used this much. Then this edit and EditAnywhere. It means it can be edited anywhere, and it is incompatible with visible. So EditAnywhere. Actually, it mainly has two places. One is edit default. When editing its default object. This is when editing its default object. It can be edited here, and this place is called the instance object. They correspond to editor default only. Editor instant only, so EditAnywhere. Both of these places can be edited. I haven't seen this much. Wait for the official Chinese translation. This is a global configuration. Let me see which ones are more important. I won't practice along with it, because some of them I haven't really used. This is related to network synchronization. This one is network synchronized. This one is not network synchronized. It will be covered in network synchronization. If you mark it as network synchronized, then this object is network synchronized. Some of its properties will be synchronized from the server at a certain frequency. Then when you receive this, you can execute the corresponding methods. This save game, that is, when we save the game, we can store it in a slot. It should be this thing, quite simple. Visible anywhere, that is where it can be seen. It is visible in terms of instance, and it is visible by default, or it can be seen everywhere. And this is the metadata tag. Here, let's directly look at what we often use. There is something here that is, this display name is something we often use. It will display the name, and this can limit the maximum and minimum values of our input. You can try it yourself. We have all displayed it here. Then this is the display priority. There is an education. This is very important. That is to say, this attribute is for my editing use. I must demonstrate this to you. This is too important. It is too useful. Then let's demonstrate it. Take a look at the others yourself. Trying this should not be a big problem. Here, we give a string. Let's just use it. This part should be written like this. Let me take a look. Okay, and here. Then we give it a boolean, but it. Then we also make it reflective. We set it to false. And here we name it like this. Now let's start it up and take a look. Good. Now let's still open our PowerPoint. Let's take a look. Hey, you'll notice why it's gray. It changed the game. It changed back again. Changed back. It's that fun. Okay. This is actually quite important. It's that we know something called an actor. When we expose it during generation, when we can spawn an actor in Blueprint, this thing is it. Good. The rest is more or less the same. So this property of ours should be done for everyone. Need to add a bit more support. Okay, hang in there. Let's try to finish this basic part. Then we can happily write code. And after writing a few thousand lines, you'll be very skilled. That's the situation. We'll be writing a lot of code, and then mainly I want to talk about this container. We haven't covered it yet, but you might have encountered it in Blueprint. If I want to place many of these dead soldiers, we can place them like this. We'll just paste this directly. My string, this is perfectly fine. This is called a one-dimensional array. That is, within an array, all its elements are of the string type. Now we have a requirement like this. What if it's a two-dimensional array? That is, if I have a two-dimensional array. Well, let's take a look first. This part is completely fine, right? So if it's a two-dimensional array, how do we expose it to Blueprint? Can we be bold? Can we write it like this? It's just what I told you. This problem is 100%. It's just that no one told you. You 100% can't figure out how to do it. Can we write it like this? Let's compile it. See? Nesting is not allowed. That is to say, this won't work. Then how should we write it? We should define a struct. I'll write this struct here. Let's copy a struct. Copy a struct. Why does mine look like this? I must have accidentally clicked the wrong one. I've already done it. It might need to be regenerated. It's fine, I'll regenerate it later. Ignore it for now. This name seems to be written wrong too. But it's fine. Put it here. Let's name it property. This P is not needed. Okay, and inside it there is a host called TOA. Pay attention. It also needs to support reflection. Otherwise, you won't see it. This is the EV number. Let's call it. one array, one strat array, an EV. Let's paste this over here. Paste it over. Okay, no problem. Then let's put this thing over here. Then let's call it true. True. Let's call it true. True. Okay, let's start now. Okay. Compilation error, right? Let's see what error it reports. Redefined. This one of ours. Change the name. Speaking of redefinition, you must never use actor character as your. Why is that? Because these engine names are already used. You will cause conflict with them. It does not allow you to override global variables. These global variables, all variables from the previous set. This is why JOGang. Many classes start with XG. It's not that KOGang insists on writing XG. It's because I don't want to conflict with the engine. I don't want to step on the engine's toes. That's roughly what I mean. Okay. But here, for you, you can see here, right? This is written wrong. It still needs to be wrapped in another layer like this. Otherwise, it's just a struct. This way it works. Okay, then let's look here. See, now it's a host. Under each host, you can also put this. It becomes a two-dimensional host. Like, he's essentially implementing a array in a different way. That's the situation. The speed is like this. Over. Regarding this part, we finished explaining the properties in Unreal. And we've also finished the practice. Of course, there's actually more, because there might be something that we'll go into detail about later. There's something called chair, and something called a thing, or something called UTF-8. I'll put this in a dedicated section on strings, because this sort of things in Unreal, so it's very comprehensive. We need to connect with the outside to be compatible. Look at these things. We won't go into detail. I'll just tell you how to use it. No need to study the underlying stuff too much. Things like charts, you can look deeper into it later if you're interested. I'll just tell you how to convert it to UTF-8. And then how to convert UTF-8 back, how to transmit it over the network. Okay, so that's it for this session. Thank you, everyone.